Hello, today we're going to talk about Dell EMC's VxRail hyperconverged solution. What we're going to focus on today is around VxRail's implementation of VMware software-defined storage solution, vSAN. Before we get started, I just want to spend a little bit of time talking about what is VxRail for those that may not be familiar with it. VxRail is a co-engineered system between Dell EMC and VMware for a hyperconverged solution in the market today. From a VxRail perspective, we are using Dell PowerEdge servers to provide the underlying hardware, and then we're using the VxRail software, which contains VMware's vSphere hypervisor as well as VMware's vSAN software-defined storage solution itself. When we look at vSAN, there's a couple things to think about. First of all, what we want to understand is that we're not running VMFS, it's not block, it's not file, it's not NFS. This is 100% object-based storage from that perspective. So when we look at how does vSAN work itself, the first thing that we look at is vSAN is going to create a disk group. And inside each disk group, you're going to have a cache SSD device. And then in addition to that, we're going to have some sort of capacity devices. One of the benefits that we see from a VxRail perspective when we look at our implementation of VxRail itself on the PowerEdge platform is that we actually specify these cache devices and capacity drives live in specific disk slots within the PowerEdge systems themselves. This allows us to meet serviceability requirements, so it doesn't matter where we're at around the world. We know that in a specific system, the first drive slot is a capacity drive for disk group 1. This also allows us to provide our customers with the ability to have predictive performance metrics across their hyperconverged solution itself. So understanding that a disk group will always contain one cache drive and some number of capacity drives, it's also important to understand that the nodes themselves can also contain multiple disk groups themselves. So here what I've drawn is basically two disk groups within the system itself where we have a cache drive, two total cache drives, and then two capacity drives. Now, these capacity drives can either be solid state drives or spinning drives themselves. We have a variety of different storage options from that perspective and storage capacities. And one important thing to note is that we cannot mix nodes that have all flash drives with nodes that have spinning drives inside the same system itself. So understanding that we are using object-based storage, the next thing to understand is how do we lay out the data? The first thing to understand is within these PowerEdge nodes, we're not doing any hardware level RAID. So in order to make sure we protect the data and we always have data availability, what we leverage is what we call storage policy-based management, or SPBM. Within those storage policies is where we specify how are we going to protect that data for an individual object, right? And then that object is going to be broken up into multiple components. So when we first look at it in the easiest form, we use something we call FTT, or failures to tolerate, right? That basically is specifying how many nodes or drives, whatever it may be, can fail within the cluster, and we can still have data availability from that perspective. The other thing we specify here is failure tolerance method. Failure tolerance method, we can either look at as RAID 1, or we can do erasure coding, which can be RAID 5 or RAID 6 on all flash systems. And we'll talk about those in a moment as well. In order to easily describe how vSAN is going to lay out the data, what we're going to do is we're going to look at FTT of 1 with RAID 1 for the protection scheme. So in vCenter, if we go in and we create a virtual machine, right, and we're just going to focus on just a single VMDK for illustrative purposes. So when we create a virtual machine on this first node up here, the first thing that VMware is going to do is it's going to look at the storage policy that we've specified with that virtual disk or with that virtual machine, and it's going to make sure that we can meet the failures to tolerate requirement. So it's going to look at this VMDK, and it's going to put a copy of it on some drive in some node. In this case, we're on node 2, the first capacity drive of that first disk group. In order to maintain availability of that, we basically need to look at how are we going to sustain that failure, and in this case, we're going to do RAID 1. So we're going to mirror that VMDK somewhere else on another drive in another node. Now that mirrored copy of the VMDK cannot reside on any of the drives here in node 2, because if we were to lose that node, we would lose access to both copies of the data. The last thing that VMware is going to do is it's going to write a small witness file. The witness file is basically like your quorum device in clustering technology. That's going to help us do the tiebreaker in the event that we can still talk to both copies of that VMDK, the witness is going to tell us which one is still active and valid from that perspective. So as we continue to create new VMs, vSAN is going to continue to place the data across the entire cluster, making sure that we have access to the data and making sure that the data is spread across the cluster itself. One of the things to think about as far as vSAN and how it handles the caching is this basically depends upon what we have from the capacity drives. As I mentioned earlier, those can be HDDs or SSDs. When we look at the caching piece, those HDDs, with HDDs, basically that cache gets divided up into 70% reads and 30% writes, versus in an all-flash system where it's used as 100% of a write buffer itself. And that's important to think about as you're looking at the system, because if you go down a hybrid-based solution, we want to make sure that we have enough cache to meet the workloads to satisfy the performance requirements for our customers themselves. So in addition to the all-flash systems having 100% of this caching tier leveraged as a write cache itself, we also bring in the capability to run data efficiency features such as erasure coding. So instead of taking this VMDK and making 2 full copies of the VMDK, we can actually take that VMDK and we can break it down into, say, 3 data bits and 1 parity bit. That now allows us to reduce the amount of storage space that we're using, because if we look at this VMDK and say it's 100 gigabytes in size, we would basically consume 200 gigs of disk space if we mirrored it versus 133 gigs of disk space if we went down the erasure coding RAID 5 side of the house. We can also leverage RAID 6 if we change our FTT to 2. But as you can see here in this drawing, to do RAID 5, I needed to have 4 physical nodes. With FTT of 2 and erasure coding, we would actually need 6 physical nodes to do 4 data bits and 2 parity bits, but we would also be able to sustain 2 simultaneous failures in the cluster and still have access to our data. One of the other things that we bring on top of the all-flash systems is the ability to bring in deduplication and compression. So that's going to allow us to save additional disk space on the back end so that we're able to go in and make sure that we're maximizing our investment of those all-flash systems themselves. When we look at deduplication and compression, what happens is, understanding again that with all-flash systems, we use 100% of a write buffer for those caching devices. So as we write the data into cache, and then we make sure that we mirror it to another cache device for persistence, as that data gets destaged down from cache down to disk, vSAN will actually look at the potential for deduplication and compression benefits on top of it as well, and then make sure that we store that data in a deduplicated and compressed format. So as you can see, when we look at VxRail in our implementation of VMware software-defined storage, vSAN technology itself, we bring some additional benefits into the system itself. First of all, one of the things we're doing is we're leveraging PowerEdge servers themselves to make sure that we're getting the latest and greatest hardware platforms for VxRail itself. We offer those in a variety of solutions, from 1U 1-node form factors to 2U 4-node form factors as well. We also look at serviceability of the system itself in defining which drive slots within the PowerEdge servers themselves are used for those cache devices or those capacity drives as well. Thank you for taking the time to watch this video. I hope you're able to find some benefit and understanding around VxRail and how we've implemented VMware's vSAN technology. Please be sure to watch some of the other videos. We will be doing one as well around VxRail and vSAN and how we handle failures as well. Thank you.